So thank you. Thank you for the announcement of the presentation. I will be presenting something about SPARQL Unicorns, namely an extension to a plugin which is already present for the QGIS system, which allows you to document RDF in HTML deployments. And my presenter doesn't work. Okay. There we go. Okay. So the basic idea is that in our university we face a lot of challenges concerning research data that we have published alongside with projects. You know, if you have a research project, what you will do is, of course, you will have publications that you will present on conferences, you will produce research software, but you will also produce research data, and there are a lot of questions concerning research data that you will have to solve when you publish research data. Hopefully you have made a research data development plan, right? But maybe you didn't do that. So these are just some of the questions you might want to answer. Which data format, accessibility of the data, where do I store my data, should it be fair data, can I make the data fair data, and so on and so forth. Many of which will also be resolved by the National Research Data Infrastructure initiatives in Germany, but they are not yet in place, and we still have research data of old projects, and the question is, how do we deal with that in an accessible manner in the case that we do not have a lot of resources to actually store the data? Because once your research project is over, it often happens that the infrastructures you used during your project will not be available after the research project has finished. So you need to think about what to do with your research data and to make it accessible for a wide variety of researchers that might be interested in your data, which you don't know beforehand usually. So, of course, what you might want to do is, if you can publish fair data, you want to publish it as linked open data. And I think most of you people know what linked open data is. So you have data that will link to other data which is related to your project, and maybe you have many artifacts in your project that you might want to interlink as well. And if you want to publish research data as LOD, well, you will be faced with a lot of different kinds of data. So here we have images, we have maybe map data, we have a 3D object that you can see up there in the middle. You have annotations on the 3D object, and they will all be hopefully integrated in a knowledge graph that you have created with common vocabularies that you reuse for the best possible interlinking of your data when you publish the data. So that's the theory why we actually want to do linked open data. And then we want to publish it fair on the internet. Now the question is, how do you publish this data on the internet? Well, you have a wide variety of options, and on the right in this graph, you can see that, okay, you might have a SPARQL endpoint where you store your data, but then you need a server to run, or someone needs to run the server. You could publish it as linked data fragments, which still requires kind of a server, or you can publish it as data dumps. And what we found in many projects is, well, we will not get any resources in our project to host any SPARQL servers or something like that. So we are basically limited to publishing data dumps, which brings us to the question, well, publishing a data dump is great if you know RDF, if you have the tools to process RDF and you're knowledgeable. But the question is, if you do not have these capabilities, can we make the data dumps that we produce more accessible? Because most of the time they will look like this. Maybe you publish some linked open data files on Zenodo, and well, that's it, right? So we see many research projects going on like this. Then you have to download it, process it, to actually find out what exactly is in these data dumps. Now the idea is that we create a tool which we have called the SPARQL Unicorn ontology documentation tool, which would simplify these data deployment. So it's currently available in many different forms. On the very top, you will see a QGIS plugin, which has been in place for an amount of years. So if you are into GIS, you can install that. I have created a GitHub action, which basically says, okay, if you have an RDF turtle file, you can use a GitHub action to generate some documentation and publish it on your GitHub page. Also available is a Python package that you can install from there, and we even have a GitLab CI workflow that you can use, which uses the same tool. And what do we do? It's basically like this. You have an RDF dump, and in this RDF dump, you will have a namespace that is typically associated with the data you have modeled in this data dump. So the tool will search for this space, for this namespace. It will give you a suggestion of which one it might be. You will confirm that, and then it will produce one HTML page per data instance, which you might know from tool sets such as Wikidata, the HTML rendering of that, or if you have been in linked open data a longer time, there has been a tool called Pubby, which would also do that just in front of a SPARQL endpoint. So it would query it live and then render the page live. Here we create pages statically, and they typically look like this. So you will see that there's a data table, which will include the different triples. And there's also always links in the slides. So if you are browsing it online, you can also see live examples of that. On the right-hand side, you will have a class tree, so the different classes and the instances in a style which you might know from the Protégé tool. And then, depending on the contents of the different linked open data instances, you will have different renderings. So here you see there's an image. So the script has detected that there's an image linked in this data, so it will also display the image for you. This works similarly for geodata, works similarly for 3D models, and for different other vocabularies that this tool can process. And you will find examples on the GitHub repository, so hosted examples, live examples of how such things could be rendered for you. Also, there will be one page which allows you to actually SPARQL the data dump in JavaScript. So it's not a SPARQL endpoint in the sense that you can ask a query and get some results, but at least you can use JavaScript to do the querying. You could also download the data dump and use a tool of your choice, of course, to do the querying. Then it also provides you options to query the graph for different vocabularies and then export different other things, like, okay, maybe you want a GraphML of parts of your graph. You can do that. Maybe you want GeoJSON, you don't want the RDF, you can do that. Or you want a CSV of different things, you can do that as well. And also, you will find that it will create a void file. If you're familiar with that, void is a vocabulary that provides statistics on your graph. And it will also try to guess what data is in your graph, depending on the vocabulary in your graph. For example, if you have geometry data in your graph, it will assign a topic to this void file that will say, oh, there's geospatial data in there. Then you will have a context menu there. So, for example, if we see on the left-hand side this little image, which is an applique annotation, you will be able to check to which other classes it is connected and by which relations. So you can access that in this class tree in a context menu, and you can check to which other instances it is actually directly connected. So this is just for purposes of navigation. And this generated class tree is also available as a JSON LD. So you can then also reuse this class tree or publish it otherwise if you are so inclined. And I cannot.
Sorry. Just making sure this.
All right. Next, we wanted to give users access to this data in APIs they are familiar to. And what you can do if you have a data dump is you can create static APIs. What is a static API? That's a collection of JSON or other documents that are in a folder structure on web space that are mimicking what an API would usually return to you. So you can generate the answers of the API beforehand. And that will not have the full functionality of an API, but it might be sufficient to give you access to a static data dump. So what we did is we used OGC API features API provided by OGC, which will give you access to geodata hosted as feature collections. So here we have a feature collection of ancient ports. It's available in RDF, encoded in GeoSparkle. And here we have the QGIS application, which uses this file path here, hosted on GitHub, to integrate it as an OGC API feature service into QGIS. So you can use QGIS to load data from your data dump, classified by the classes that are encoded in the RDF that you see on the left-hand side. So that's one example. Second example, we can generate IIIF static APIs. So here you see a IIIF viewer, which is Mirador, which will access the generated static API of IIIF and provide IIIF clients a way to query the images. It will not be able to change the images. It won't be able to rotate the images, what IIIF usually provides you, but it will be able to download the images. So that's another example of what you could do. Third example, implemented a CCAN. So I showed you before we can generate data exports. So why not use the CCAN API to expose these data exports so that you can download them? So that is also possible if you want a CCAN export. Now, to put this a little bit into context, what are we achieving with this tool? So if you are producing linked open data, we will be in this research data lifecycle in several steps. So this script can help you in publishing research data, and it can hopefully publish it in a way that many research communities can interact with, like they are used to interacting with data in their respective community. It will also help you with archiving research data, because you can, of course, archive these HTML dumps that the script will produce. And it will also enable you to make your research data more discoverable. What we have seen, and we work a lot, for example, with archaeologists, when they see an RDF file, they will not be able to tell you if that is useful for them. But if they see an HTML rendering and what is inside, they might consider it for their research. And that's usually what you want. You want exposure for your research and the data reuse. Also, it might simplify data analysis and processing because you have more formats that you could possibly process by generating the different formats. Which brings me to the conclusion of this talk. Well, we have experienced now in many research projects that, well, producing linked open data dumps is good, but it's usually not enough. So we need linked open usable data dumps, as we now framed it in this presentation. So we need deployments of RDF data which provide HTML renderings for navigation, additional data exports for more communities, and ideally data access in static APIs that communities are actually willing to use and can make use of. And we believe that if we can publish linked open data dumps this way, they become more accessible, more reusable, and possibly will maybe also further the adoption of linked open data in different other communities. Lastly, a look at what are the plans for the future work of this script. Well, an idea is to generate public solid pods, if you are familiar with that. So there's one way of publishing linked open data, which can also publish restricted data, but here we could possibly format it to publish public solid pods. And of course, then a huge task is the integration of further vocabularies, data types, APIs, and so on, and to improve the HTML templating. And with that, I'm finished, and I'm waiting for your questions. Thanks.